This is your standard big block Chevrolet solid roller cam. Crazy big. I think that this must be a 70 millimeter core. This is my SMX sleeve. Isn't that something? This is big block Chevrolet head gasket. Check that out. Is that crazy or what? All right, what we're doing today is we are going to take this all billet. Now, gotta backtrack up a little bit. This is not my block. I did not build this billet block or billet cylinder heads. This is a Sonny's Automotive one. All right, big, Hemi cylinder heads. In fact, I mean, look at how big these heads are. They are massive. I'm gonna show you some stuff because this engine is a 5.3 bore space big block Chevrolet Hemi headed engine for Camille's crazy insane jet boat slash jet ski slash crazy concoction that he's got done up. Look right here and you'll see the link down below in the descriptions. You can go back and see that video because you'll see the whole boat and it's pretty crazy. But this is the actual engine build. We're going to start going over the whole thing with you. But right now, we're getting this ready. We're going to go over to the hard anodizer, and we're going to get this entire block hard anodized. That's different than regular anodizing. Different than regular anodizing. Hard anodized, cylinder heads, block, all the water plates, everything. I'll show you real quick because we're going to do more coverage of this entire buildup, but right now we're just going to mainly focus on how the hard anodizing works. We're going directly there. I'm going to show you the whole thing, how hard anodizing works, what it actually is doing to the material. But this is fully water jacketed, very similar to my SMX, the way they plated on the inside, plated on the outside. A little bit different. Some things that I'm not a huge fan of, but aren't a big deal, just a personal preference kind of thing. They do have these the blocks are machined up very nicely. Pretty deal. You can see the whole lifter valley area here. Huge 1062 lifter bores. I mean, there's really some crazy good stuff here. And also, I gotta verify what all it is, but this is a big freaking cam core. Let's see if I got a big block Chevrolet camshaft here. A standard big block Chevrolet camshaft. I'll show you a difference real quick. And then I'll show you a difference of some other stuff on my SMX to this. But this is going to be 800 and we can make it bigger, but I didn't want to. It's going to be 800 and I think 87 cubic inches is what the final size of this engine is going to be. Crazy big. Let me grab a big block Chevrolet camshaft and I'll show you something real quick. This is your standard big block Chevrolet solid roller cam. Okay, big block Chevrolet solid roller cam. In fact, this would probably this particular cam, I mean, we make, upwards of 2,500, 3,000 horsepower on standard core stuff. Check this out. Crazy big. I think that this must be a 70 millimeter core. So it's standard core. Crazy big. All right. Other thing that I would also find interesting is, so the sleeves for this engine, I thought that is a big freaking sleeve. Big bore, 4950 bore. Check this out. This is my SMX sleeve. Isn't that something? My entire sleeve fits inside of their sleeve with room. So anyways, pretty crazy stuff. But we do have to have all the steel out of this before we can take it there. We can apparently leave brass in it, which is interesting. So we're going to get all this stuff over to the hard anodizer and show you and talk to you about hard anodizing. Before we go over there, one more thing on the size I think you'll find is interesting. When I say it's a 5.3 bore space, if you don't know what that means, It is the distance in between each bore, which allows us to have this great big cylinder that's actually bigger than the OD of my sleeve in my SMX. This is Big Block Chevrolet head gasket. We'll line it up with one cylinder bore right here. This is a 4500 bore Big Block Chevrolet, so this would be your typical 540, 572, anything like that. Check that out. Is that crazy or what? Huge difference in physical size. So gonna be really fascinating. Hey, don't forget, we got merch also. You can see I'm wearing a Dewey shirt. All out of the Dewey shirts, we have reordered Dewey shirts. So we are getting those, but we have long sleeve, kid sizes, and Dewey shirts. All our normal stuff. Make sure you go there, check out it on the website. And hats. I do have a boatload of hats though, so that's all good. All right, so we're here at Premier Finishing. This is my first experience with hard anodizing on my own. We have our pistons are hard anodized, but I don't have it done. It's just done by Diamond, and they do it, and so I've never seen what the process is. This is Joe.
Yep.
Joe,
how you doing?
Is helping us out here and explaining exactly what's going on. So in hard anodizing, it's not regular anodizing. Regular anodizing is just
Yeah, so the main difference between regular anodizing and hard coat anodizing is going to give you a much thicker coating. So when we do the anodizing, we're using more current, more amperage through the part itself, and that's generating a much thicker coating than you would with a normal anodize. So it's going to give you more corrosion protection, it's going to give you more hardness, and just a more robust coating.
Yeah, so how thick is it then?
So we're
roughly
looking at 2 thou is the thickness of the actual coating itself. Then you're going to see a growth of about 1 thou per surface. Compare that to a normal anodize. If we were doing like a colored anodize, you're talking 6/10 of a thou, so it's quite a bit thicker.
So so it impregnates the anodizing goes in a thou and then comes out a thou.
Yeah, so you're using the base aluminum to make your aluminum oxide, which is what anodizing is. So you're using current and the electrolyte in the tank itself to create aluminum oxide, and that's what is giving it its hardness.
Okay. And yeah, so little side note, like you said, hardness is like this stuff is, I don't know what the Rockwell is, I don't know, but it's file hard. I mean, you can run a file across it like the file across the pistons. It's hard.
It's basically one of the hardest substances that we can make synthetically. Really? It's hard to get a real true Rockwell hardness because the base layer is still just aluminum. Yeah. So if you try to do any testing in that, you're still going to have the softness of the aluminum under it.
Right.
But I've seen anywhere from like 60 to 80 Rockwell, depending on what website you read as far as how hard it is. So it's very hard. So yeah.
And then another interesting side note I did not know, and is regular anodizing like this also does not conduct electricity. So when it has, so for example, we anodize everything here. If we need to put an engine ground on the engine, it has to be ground off in order to conduct electricity. It will not ground through anodizing. Yep. And even regular anodizing like that?
Yep, any anodizing. So aluminum oxide itself is non-conductive. So when we create that aluminum oxide layer, again, that takes away the conductivity. So what'll happen a lot of times with applications where we need to have current run through the part after it's done, we'll either mask off an area, plug a hole, or again machine it afterwards to make sure we can get that content.
Which reminds me, because one of the things that I will have to have you do is spark plugs have to be grounded. So I'm going to have you plug the spark plug holes in the cylinder head, because there's no way I'm getting down in the hole and getting bare metal once it's done. So we're going to plug the holes for the spark plugs, so the spark plugs will ground.
I don't know a lot about engines. I would assume that it probably wouldn't work very well if you're not getting a spark in your spark
It will
plug,
not
right?
work at all. Yes, it will not work at all.
Right.
Okay, cool. So we've kind of gone over stuff here. Really interesting stuff I didn't know about hard anodizing. It does make it tough. The whole reason we're doing this is because it's a marine application. It's potentially could go into salt water, which is a mother trucker on everything.
Yeah.
And just regular water gets corrosive. So that's going to be really cool. Would it be possible to see the tank that it goes in?
Yeah, absolutely. Yep, we'll take a trip up to our anodizing facility.
Okay, sweet.
Well, let's go ahead and walk over there, I guess, and then I'll just kind of give you the basic rundown.
Hey, what's that little machine doing?
Yeah, don't take pictures.
Oh, don't think me.
Yeah.
Sorry. Top secret stuff back there. Can't see that.
So yeah, let me give you the rundown, and then we can talk about the anodizing tank itself. So anodizing is essentially a process, again, that's taking the aluminum and turning it into aluminum oxide. So just like any finishing process, your first step is going to be to clean the part, to remove any lubes, oils,
Yeah.
Dirt, grime, whatever from the part itself. And then for most of the anodizing that we do, we would go to a caustic etch tank, and that's going to remove any corrosion that might be on the part, and it's also going to matte the part out. If a customer wants parts to be shiny, kind of like that is now, we would want to skip that process. So we can talk about that with this particular part if we don't want to do that or not. So
Let's make it shiny.
we want it shiny.
I've actually wondered why that is, because I've seen shiny anodizing.
Yep.
And I've seen dull, and most anodizing is dull.
Yep, so a lot of anodizing will go through this caustic etch process. A lot of customers want it to be more of a matte. The other thing too is with your parts is you've machined almost all of it.
100%.
So the issue of corrosion is not as big of a concern. Yeah. So what we'll do then is skip that process. If we didn't skip that process, what will happen on the part is, again, we remove a very small amount of aluminum, but we leave the alloying elements on the surface, the copper, the zinc, the magnesium. So we need to remove that afterwards. So then it would go into this tank, which is our deox tank. And that is a tank that is several different types of acids, and that would remove those alloying elements from the surface. So part comes out of the caustic etch tank, it's going to be very dark looking, it's not going to look like aluminum. It goes into our deox tank, those alloying elements are removed, we bring it back out, and then as you can see on these parts, it looks like regular aluminum.
Yeah. Okay.
And then the magic happens. We have two tanks here, one for our type 2 anodizing, one for our type 3, which is hard coat anodizing. They essentially are doing the exact same thing. It's just the type 3, the hard coat tank, is more of everything. So where we may be running 12 to 15 volts per square foot, amps per square foot with type 2, we're running 36, so we're 3 times the current.
You need to look at the power cables here.
Yeah, so that's the juice going to our cathodes.
Yeah,
So
that's power.
It's called anodizing because the part itself is the anode, and then we have copper plates on either side, and those act as the cathodes. So you're running current between the anode and the cathode. It's pulling the oxygen from the sulfuric acid that we have in the tank, combining that with the aluminum and making aluminum oxide. So that's how anodizing works.
Sulfuric acid.
Yep. So these tanks, type 3 and type 2 anodizing use sulfuric acid, and that's what are in those tanks. And again, that's what's helping create that process along with the current that we're running through the parts.
Yeah.
Yeah.
Dang.
So what you're doing is you're creating these hexagonal pores on the surface of the part. So as the aluminum oxide grows, you're creating those pores, and then consequently those pores act as very, very good receptors for our dye process.
Oh, so then all right, so then it would go to the dye.
So we would anodize it.
What color is it when it comes out of here?
So it's going to depend on the alloy of the aluminum. So in general, when you anodize, it's going to get a lot darker. But again, depending on the alloy content, it's going to look different. So 7075, for example, high copper content, it's going to look almost like a goldish color when it comes out. 6061 is typically a dark gray or drab olive looking color.
Okay.
It also depends on the thickness of the hard coat.
Okay.
Standard hard coat is 2 mils, 2 thou, and that's what we'll
when they do when they do different color anodizing, that's a type 2 anodizing.
You can do colors with either hard coat or type 2.
Oh, right. Because I mean, like, they have some pretty nice, like, really red.
Yep. Yeah. Generally, for colors, you're doing a cosmetic anodize, which is going to be the type 2.
Yeah. Okay. Gotcha.
So we offer here blue and black.
Yeah.
So we'll be doing your parts in black.
Yep.
So essentially, the dye fills up those pores that we've created in the aluminum oxide. We leave it in the tank long enough for what's called full saturation. So if we were to put parts in there for a couple minutes, it may have like a bluish purplish tint. It's not going to be a real deep black.
Yeah.
So we leave it in for full saturation, which fills up those pores completely with that dye, and it's going to turn it a really nice deep black.
Okay.
And then after that process, after the dye process, you need to seal the part. So the sealing is essentially just creating a chemical barrier on the surface of the part that's going to keep the dye in the pores, and it's going to also help offer a lot of that corrosion protection that you get with anodizing.
All right.
So, yeah, and then from there we rinse it, we dry it, we unrack it, and
ready to rock and roll.
Yeah.
Wow. That is all pretty goddamn fascinating.
Yeah.
So I didn't know any of it.
Yeah.
So that's really cool, and all that power over there is slightly nerve-wracking. It seems to be exposed.
Yeah. So you can touch any of the bus connectors to the cathodes, all that stuff. It's completely safe.
Really?
Yeah.
Oh, because this is only one side of the power. The other side of the power is on the
Yeah,
other
if you
side.
start getting into the rectifier itself, that's where you might be able to get yourself in trouble.
Well, it looks scary, but it's not.
Yeah, it looks scary, but it's not. Yeah, exactly.
All right, cool. So I think we're all done here. We're going to sign up or fill out paperwork and all that crap, and let's head back to the shop. All right, we're back. I think that's super interesting on that whole anodized thing. Hope you like it. Comment about it if you'd like. Also, hey everybody, like, subscribe, share the thing, because we're trying to get people to watch, and it helps us out a lot. So please subscribe. It doesn't cost you anything. Unless you're a channel member, you want to be a channel member, that's different. But subscribe, that's easy. Doesn't cost anything. Helps us out a lot and gets you notifications. So hit the subscribe button right here and the notifications, and then you get notified when we have stuff. Something that is going on really quick coming up. I got invited. If you watch Cletus's channel, you'll see that I got invited to go run the Bristol 1000. Now, Garrett actually forgot that I have already run one of his races. I went with Bailey to the Mullets race, the 24, what is it, 24 minutes, whatever it is. 2.4 of Le Mullets. I did that race already. I can circle track drive. I can turn left. And he also tells me, he says, hey, since you're going to do this, you need to do a burnout car. I go, I don't have a burnout car. I ain't using this car for a burnout car. I'll tell you that right now. And I go, okay, let me think about it. Cool. I am building a burnout car. It is top secret crud. You're not going to see it. Here's what here's the black blob that it looks like. Not the whole shape. Got to really fuzz it out. But anyways, it's going to be, I think it's going to be really cool, because I do not want to do something that is just half butt. I'm not just showing up in a pickup truck and going to do a burnout. I'm not going to show up in whatever and just do a burnout. I want to do something cool. You're going to see it. I think it's going to be really neat. I think it's going to get a lot of attention. So we got that whole thing going on too. Come back tomorrow. The Clark origin story. You've asked about Clark. Clark's my buddy. Clark's not around working as much as he's supposed to be. But we're going to do the Clark origin story. tomorrow be here. So anyways, like, subscribe, share, and comment as much as you can. It just helps us out, keeps the, keeps traffic up, and it does help me. So I appreciate all of you guys. Have a great day.